It feels like AI has completely leveled up recently. I mean, it's gone from just answering our questions to, well, to actually doing things. We're seeing these systems now that can plan, that can use tools, that can tackle really complex projects all by themselves. This is the world of what we call agentic AI. And today, we're going to go under the hood and really unpack the architectural blueprints that make these thinking machines tick. All right, let's get into it. And listen, the claims being made out there they're pretty bold. I mean, take the SOMA project. They describe their architecture as, and I'm quoting here, fulfilling the essential requirements for AGI Level 1. Whoa, AGI Level 1, that's a massive statement. We're talking about the first real measurable step towards artificial general intelligence. So yeah, the stakes are incredibly high. So that really brings us to the core question, doesn't it? What does it actually take to build an AI that can think and plan and act all on its own? And look, this isn't magic. It's about engineering. It's about figuring out the fundamental components, the design patterns you need to create a truly autonomous, intelligent agent. So let's break it all down. Okay, so before we even get to the blueprints, we have to talk about the tools, right? We need to know what we're building with. Any intelligent agent needs a very specific set of core capabilities. Think of it like this. This is the essential toolkit, the absolute must-haves for any AI that's going to go out and operate on its own.
And if we use that AGI Level 1 system as our guide, it really boils down to 4 key things. First up, planning capability. That's just the ability to make a roadmap to get from A to B. Second, you need modularity, which is basically having different parts that can handle different roles, kind of like a team of specialists. Third, and this one is absolutely crucial, is self-reflection. It needs to have feedback loops so it can learn and get better. And finally, tool use. It has to be able to actually interact with the digital world to get things done.
Let's zoom in on that idea of a feedback loop for a second, because this is really the engine of learning. The concept itself is simple, but it is so powerful. It's basically do a thing, check how well you did against the goal, and then use what you learned to do it better the next time around. That right there, that's how an agent stops being a simple command follower and starts actually adapting and improving all by itself.
But here's the thing, just having all the right parts isn't enough. You can't just throw a planner, some tools, and a feedback loop into a pile and expect intelligence to just happen. It's like having all the parts for a car but no assembly instructions. They need to be organized. They need a coherent structure. They need an architecture, a blueprint for how intelligence is put together. And as it turns out, there are some pretty well-established patterns for this. And that's what we're going to do now. We are going to unpack 5 of the most important blueprints out there. These are the dominant architectural patterns that engineers are actually using right now to build these amazing AI agents.
Okay, think of this as our cheat sheet, our map of the territory. We've got our 5 architectures laid out. And what I want you to notice right away is the control column. You see this massive difference, right? You go from a totally centralized, top-down approach in the hierarchical model all the way to a completely decentralized, bottom-up system with swarms. And you can see how that one choice, how you manage control, directly shapes what each architecture is good for. It tunes them for completely different jobs, everything from industrial robots to the AI co-pilots we're all using.
All right, first up, the Hierarchical Cognitive Agent. The best way to think about this is like a corporate org chart. Seriously. At the bottom, you've got your frontline workers. That's the reactive layer, handling instant reflexes. In the middle, you have your managers, the deliberative layer, doing all the tactical planning. And way up at the top, you've got the C-suite, the metacognitive layer, setting the grand strategy. This top-down structure gives you really clear, predictable control, which is exactly why it's the go-to for things like industrial robotics, where safety is absolutely non-negotiable.
Okay, next we have swarm intelligence. And this one is the total opposite. The perfect analogy? An ant colony. Think about it. There is no king ant giving orders. There's no central command. Instead, you just have thousands of simple little agents, and each one is just following a few very simple local rules. But, and this is the magic part, out of all those simple local interactions, this incredibly complex global behavior emerges. Suddenly they're building intricate nests or finding the fastest way to a food source. This makes swarm systems super robust and easy to scale up, perfect for things like coordinating a fleet of drones or simulating traffic flow in a city.
All right, blueprint number 3 is the meta-learning agent. And the whole idea here is learning how to learn. Let me give you an analogy. Imagine a great basketball coach. The coach can teach a player a specific move, like a free throw. That's the inner loop, learning one task. But the real genius of a great coach is teaching that player how to learn new skills faster on their own. That's the outer loop, the meta-learning. It's all about optimizing the learning process itself. You're making the AI better at getting better. And this is why it's so powerful for things like personalized assistants, because they can adapt to you super fast without needing mountains of new data.
Next up is the modular agent. And honestly, this is probably the most common pattern you're going to see out in the wild today in systems like all those AI co-pilots or that Soma project we talked about at the start. The best way to picture it is a team of specialists. You've got one module for perception, another for memory, another one for using tools, and then you have this central orchestrator, like a project manager, who knows exactly which specialist to pass the ball to for each part of the job. The beauty of this is its flexibility. You can just plug in a new tool or a new skill as a new module. It's super composable.
In our last blueprint is the evolutionary agent. The analogy here is pure Darwin, survival of the fittest. Here's how it works. You start with a whole population of different agents. You throw them at a challenge, and only the ones that do the best get to survive and influence the next generation. Then, you make the challenge harder, that's the curriculum, and you repeat the process. Over many generations, the population evolves these incredibly sophisticated and often totally unexpected strategies. It's an amazing way to discover brand new solutions in really complex competitive spaces, like in advanced video game AI. So there you have it. 5 totally different blueprints for building intelligence. Which of course leads to the obvious next question. Okay, so which one do you pick? And the answer is, it's never about which one is best in a vacuum. It's always about choosing the right tool for the job you need to get done. Let's take a look at what that means in the real world.
And this chart just lays it out perfectly. If your problem is high-control robotics, something where you need predictable, safety-critical control on an assembly line, you go with the hierarchical blueprint, no question. If your main job is juggling a bunch of different software tools and APIs, like a modern AI co-pilot does, then the modular blueprint is your best friend. And if you're dealing with a huge, spread-out spatial problem, like managing a fleet of delivery drones, the swarm architecture is the natural choice. And this really gets to the crucial takeaway of this whole thing. Today, when you hear about someone building an AI agent, it's not really about just training another huge model. The real work, the real innovation is happening at the architectural level. It's about making a design choice, choosing and implementing the right organizational structure for intelligence to operate within.
But wait, the story doesn't actually end there. Because the most cutting-edge systems out there, they aren't just picking one of these blueprints. Nope. They're starting to combine them, leading to these incredibly powerful hybrid designs.
And why are they doing that? Because real-world problems are messy. You know, they rarely fit perfectly into one clean little box. So the smartest systems don't just pick one blueprint and call it a day. They mix and match. They create these powerful hybrids. It's all about taking, say, the super tight control of a hierarchical system and combining it with the awesome flexibility of a modular one. You get the best of both worlds, and you end up with something way more robust and capable than either one could ever be on its own. Let's make this super concrete with a couple of examples. Imagine that swarm of search and rescue drones. The overall group behavior, that's the swarm blueprint. But inside each individual drone, it might be running a hierarchical system for its own precise flight control. See? 2 blueprints working together? Or how about this? Think of that modular agent with its project manager orchestrator. What if that orchestrator itself gets better at its job over time using a meta-learning blueprint? It literally learns how to delegate tasks more and more efficiently. These hybrid approaches, they're creating a whole new level of intelligence. And all of this brings us to one final big picture thought. As we get better and better at not just understanding these blueprints, but choosing them, combining them, and building with them, it really makes you wonder, are we just building smarter and smarter tools that are really good at following our instructions? Or are we, piece by piece, blueprint by blueprint, actually laying the architectural foundation for something much, much more? Something like a truly general intelligence.